Hello, my name is Manuel Ignacio Ayala Joven, professor at the Universidad Tecnológica Indoamérica from Ecuador. The topic that I will explain is the life cycle assessment of electricity generation transition in Ecuador. The text is introduction, method, results, evaluations, and conclusions. You can see here the map of National Interconnect System in Ecuador. Now, introduction. This is the location of Ecuador in the world here, and here is Galapagos, part of Ecuador. Ecuador's energy mix has greatly reduced its dependency on fossil fuels the last 15 years, down to a marginal role 5% in electricity generation in 2017. Now, you can see here the thermal generation in this part, the red, and the development plan of Equatorian Power Network aims to keep the adding hydropower to meet the increased demand. You can see here new projects, hydroelectrics with dams, and if you compare the energy mix on 2012 and 2020, Ecuador went from a 36 dependency on thermal generation and 18 on imports to being self-sufficient with a 90% of renewable generation. You can see here in 2012, 46% with renewable generation, and in 2020, 90% with renewable generation. In this study, a prospective life cycle assessment LC8 of different power generation projects implemented in Ecuador was performed in order to determine the feasibility of the development plan and its environmental sustainability in a long run. And you can see here first is the objective and scope and bound, and after this life cycle inventory and life cycle impact assessment. This is the interpretation of the LIC. You can see here the method is based on the following steps. The first step is the initial definition and boundary system for LCA. After this, consideration like a manufacturer, transportation, operation state, and data collation per component and state. After this, you as a verification of the information and life cycle impact assessment with GEMIS. GEMIS as a software with the global emission model for integrated systems. And finally, plots the results. And this is quantitative analysis of the energy transition over the entire life cycles. The simulation software GEMIS, global emission model of integrated system, was used. The global emission model for integrated system GEMIS is a European life cycle analysis database program provided by INAS, International Institute for Sustainability Analysis and Strategy. The result of this analysis is that the GEMIS gives a detailed description of all the process steps and the energy system and the calculation of primary energy consumption involved in the process, the emissions and the mass and energy flows. We use this model in order to calculate life cycle emissions of power plants. The simulation performed with GEMIS yields a project demand of 114,252 gigawatt hours with in 2050 This result is very close to that obtained by the Ministry of Energy of Ecuador. More similar results, and you can see here the result with the software, and you can see here the results for others methods with the Ministry of Energy of Ecuador. Now, the total cost amount to 1% GDP, gross domestic product, which is 6,380,171 million US dollars. Although the analysis is not comprehensive without that in prices, inflation, etc., but the results are a good reference. And their CO2 emissions are calculated considering the full life cycles. In general terms, the following life cycles were considered: 50 years for a large dam hydroelectric plants, 20 years for solar and wind power plants, and 15 years for thermal power plants. Now, the evaluation, the sustainability in the indicators of 2012 are compared with those of 2015, and the influence of the integration of renewable energy is determined. The main indicators are the share renewable energy reduces of tons of CO2 for each megawatt hour, and however the CO2 emissions will double due the increase of number the consumers logically. This is the 3 points, very important points, and you can see the results in all the case improve the ambiental considerations. LCA studies conclusions can be used to forecast the future environmental impacts of a power network. This article explores the sustainability of the power network around the plan envisioned by the Ecuadorian government through 2015. The participation of renewable energy is relevant since it's close to 90%, which is reflected in the lower emission per megawatt hour generated, which is a 65% reduction compared to 2012 emissions. And hydroelectric energy is the main primary energy source with 78% share due to its great potential for expansion, since the rivers that flow into the Pacific Oceans are complemented by those flowing into the Amazon basin, minimizing the effects of droughts. Every energy transition in Ecuador follows the path of sustainability development with appropriate technologies, socially acceptable and economically profitable. Thank you very much for your attention.